Thanks for joining me today for a Earth Science Lesson 1. This is about exploring the Earth's crust. This is primarily an Earth Science unit, but there are some extension activities that go into the physical chemistry and the biology aspects of the Earth's crust. Thank you for joining us, and we'll be doing a project video later on that's related to this.
Welcome back, everyone. If you're here, you're looking for a clear, structured understanding without all the fluff, and honestly, you are in exactly the right place. Okay, let's dive into this. In today's explainer, we are looking right beneath our feet to understand the absolute, literal foundation of our existence, the Earth's crust. We're going to break down exactly what it is, what it's made of, and why it is literally the only reason you and I are here today. So here is our syllabus for this explainer. We're taking a macro to micro to macro journey today. First, we'll look at the big picture. Second, the two types of crust. Third, the elements and tectonics. Fourth, Earth's life support system. And finally, a quick recap. All right, part one, the big picture. Before we can truly understand the crust, we really gotta zoom out and look at the whole planet. Think of the Earth like a giant onion, or actually a hard-boiled egg is a pretty perfect analogy here. Down at the very center, you've got the inner core. It's solid iron burning at 10,000 degrees Fahrenheit. Just to put that into perspective, that is hotter than the surface of the sun. Crazy, right? Wrapped around that is the outer core, which is this constantly spinning layer of liquid iron and nickel. Above that is the mantle. Think of that as the thick egg white made of super hot, semi-solid rock. And finally, sitting right on top is the outer shell, the crust. For this explainer, we are going all in on this very first layer. Moving.
Don't miss the action. Please like and subscribe now for me, please. It keeps me in the algorithm. Otherwise, all these great videos just die on YouTube after a short time. Thank you, folks. Have an awesome boxing day.
Right along to part two types of crust. So the crust is the outermost, hardest, and coldest layer of our planet. But here's the thing, it is not all the same. There's a really stark contrast between the two distinct types of crust we have on this planet. Now, what's really interesting about this is how cleanly they divide. Let's do a quick memorization chant together. Continental, thick, light, granite. Oceanic, thin, heavy, basalt. The continental crust forms, you guessed it, the continents. It's the land we walk on every single day. It's incredibly thick, stretching anywhere from 20 to 50 miles deep. It's made mostly of that lighter granite rock, and man, it is ancient. We're talking parts of it being over 4 billion years old. On the flip side, the oceanic crust sitting underneath our ocean floors is a whole different ballgame. It is way thinner, only about 4 to 6 miles thick. It's made of a heavier, darker rock called basalt. And unlike those ancient continents, oceanic crust is actually relatively young because it is constantly getting recycled down at the ocean floor. Now, I want you to just pause for a second. To truly grasp the insane scale we're talking about, imagine the Earth shrunk down to the exact size of a standard basketball. The crust, that entire massive layer we just broke down, would be thinner than a single sheet of paper wrapped around that ball. Let that sink in. Every towering mountain range, every deep ocean, every sprawling city, every single living thing that has ever existed in the entire history of the world, all of it exists entirely on a layer thinner than a piece of paper. Okay, let's pick the energy back up with part 3, the elements and tectonics. So what exactly is this paper-thin layer actually made of on a microscopic elemental level? Well, by weight, 46% of the crust is oxygen. Wait, what? You're probably thinking, oxygen, like the invisible gas we breathe? Absolutely. But down in the crust, it isn't floating around as a gas. It's locked incredibly tightly into solid minerals. Oxygen is literally the most abundant element in the solid ground you walk on. Mind-blowing, right? It bonds with silicon to form this massive group of minerals called silicates. Silicates are the most common minerals on Earth. In fact, that granite we just talked about is absolutely packed with them. Throw in some aluminum, iron, calcium, potassium, sodium, and magnesium, and those 8 elements alone make up over 98% of the entire crust. So the next time you're standing outside, just realize you are literally standing on compressed oxygen, silicon, aluminum, and iron, all shaped into rock over millions of years. But as you know, that rock isn't just standing perfectly still. The crust is actually fractured into these massive sections called tectonic plates. Think of them like giant, heavy puzzle pieces floating right on top of that hot, semi-solid mantle. They move incredibly slowly. We're talking about as fast as your fingernail actually grows. But over millions of years, that tiny movement reshapes entire continents. Where these massive plates pull apart, crack, or slam into one another, they release absolutely staggering amounts of energy. This dynamic movement is the exact reason we have earthquakes. It's how our greatest mountain ranges are violently pushed up into the sky, and it's why we have volcanoes. Which brings us to the big payoff in Part 4, Earth's life support system. Here is the central mystery we really need to solve. Why does all life exist only on this single paper-thin layer of the Earth? I mean, life doesn't live deep in the mantle, and it certainly isn't hanging out inside solid iron at 10,000 degrees. It survives right here, specifically because of 4 vital ingredients the crust provides. Let's stack these up and see how this builds. Number 1, cool temperature. Thanks to the geothermal gradient, it gets intensely hot very, very quickly as you dig down. Only the very top of the crust provides that narrow, Goldilocks temperature range that life absolutely requires. Number 2, a solid surface. Complex life needs an anchor. You simply cannot build a thriving ecosystem on moving, molten lava. Number 3, liquid water. Water is the single most important molecule for life as we know it. Below the crust, the extreme pressure and heat would instantly vaporize or destroy it. And number 4, the atmosphere interface. This is that crucial zone where the solid ground meets the air, allowing sunlight to actually reach the surface. It makes atmospheric oxygen accessible and allows carbon and nitrogen to cycle naturally through the environment. Listen, if you remove even one of these 4 things, life as we know it completely ceases to exist. Ultimately, the crust is basically Earth's life support system. Our existence here isn't just some happy accident. We are here specifically because of the crust's exact position on the outer shell, its exact paper-thin thickness, and its exact chemical composition of oxygen and silicates. Let's bring this all home with Part 5, the recap. We have journeyed all the way from the burning center of the Earth right up to the rocks outside your front door. So let's lock in the rule of 3s we just covered. First, what it is. The crust is the outermost of the Earth's 4 layers, split between thick granite continental crust and thin basalt oceanic crust. Second, what it's made of. It's composed primarily of oxygen and silicon, bonding to form silicate minerals. And third, why it matters. It provides the precise temperature, solid surface, water, and atmospheric interface that forms the perfect recipe for all life. This is the literal, scientific foundation of everything living on this planet. So, what scientific topic should we tackle next to understand our planet? The structure of the Earth is really just the beginning, and there is so much more out there to uncover. Think about what fascinates you the most about the physical world, because your curiosity is exactly what drives these explainers. Keep engaging with the material, don't just passively consume. Thrive in your learning journey, and I will see you in the next explainer.